lesson, we are going to continue building our checklist of tools that can be used to explain why triangles are congruent. So far, in our work with congruent triangles, we've been able to use the definition of congruent triangles. And we'll, of course, recall that one means that we have to have 3 pairs of congruent angles and also 3 pairs of congruent sides. A long checklist of 6 things. After that, we've built in the checklist for side, 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 only needing the 3 pairs of sides to be congruent, and then it will force all of the angles to be angle pairs to be congruent as well. Additionally, we built side angle side, which was used to go through and show we had an included pair of angle, or an included pair of angle congruencies, and then 2 pairs of congruent sides. Well, we've got 3 new tools that we're building today. We are going to see the angle side angle congruence theorem. We will see angle angle side, and we will also see hypotenuse leg. Again, these are just different checklists that you could use for any particular problem. These different checklists will tell you, are these triangles overall the same, yes or no? Moreover, though, we're not going to spend as much of our time actually doing proofs with this video. We're going to look at some of the applications for triangle congruence, starting to build a little bit toward that direction. Only piece of vocab that we need is an included side. You'll likely remember from our earlier videos that an included angle was one like this. And it was considered included because it was created by a pair of angles. So the angle was created by a pair of sides. So it was kind of the in-between angle. Well, an included side then is created by a pair of angles. You could think of it then, if you've got your pair of angles, the included side is the one that's in between them. That would be here, PQ is in between these ones. Having the included side will, of course, be a component for one of our checklists. Well, first one we've got is angle side angle. Well, we're working angle side angle. It's a lot like side angle side. It's telling us, the name tells us exactly what we need. We would need a first pair of angles. We would need a second pair of angles. We would need 1 pair of sides. And just like we had an order to side, angle, side, this has the order as well. We need to have the included side. That included side is what guarantees us that we've actually got angle connecting to side, connecting to angle. And in terms of the picture for it, all we're really looking at doing is saying if we have a known 35-degree angle connecting to a known 4-centimeter side, connecting to a known 60-degree angle. So basically, if we know that we have the conditions, angle, then side, then angle, with actual numbers, how many different ways are there to finish off a triangle like this? The only thing we could do is extend this outward and say, we know that the side has to be somewhere on there to maintain the 35 degrees. We know that the side has to be somewhere along there to maintain the 60 degrees. Wherever they intersect, that's all we've got. And I'm not sure if you remember, but a while back we were doing some work with the compass and protractor, creating some of these pictures. That's why we were doing it. Now, one really common type of problem that you'll use for angle side angle is actually, and I forgot the word there for a second, sorry, but it's like finding your bearings. If you're out flying an airplane, how do you decide where to point the airplane? If you're steering a ship out in the ocean, where do you actually point the ship so that you'll be able to get to where you want to go? Well, bearing problems like that are used for navigation. Now, one piece that you need to be very, very aware of is when we put a piece down here to go from a point A over to a point B, the bearing is north 65 degrees east. I'm betting that you're not familiar with what that's saying. Well, this would tell us if we are starting at a point A and going to a point B, we could have a basic coordinate plane built right there. On the north axis, okay, so going in the north direction, create a 65-degree angle on the east side. Please notice then that's saying the 65-degree angle is going to be based here. 65 degrees, it's being built on the north axis, not on the east axis. The distance there would be a total of 8 miles. And where you stop, that's point B. Well, now we would continue our navigation. From point B to point C, we would say north. Okay, so once again, we're building on the north axis. Create a 24-degree angle on the west-hand side. So on the north axis, we're going to create in, this piece would be 24 degrees, and I have absolutely no clue how far we're supposed to go. I don't know a distance. So I don't know if we're supposed to be stopping right here, or if we're supposed to continue a really long ways. We're not given a distance. But we would know somewhere, eventually, we're going to reach a point C. And I'm just taking a blind guess that that's where C is. I really don't know where it's going to be. But I do have another bearing so that from point C to get back to point A, our original starting point, we would have to create on the south axis a 20-degree angle. So going south, create 20-degree angle, and that piece right there is where we get our 20 degrees. This type of changing directions, this type of navigation is what they've actually needed to do for a couple hundred years for ships, a couple hundred years for airplanes. And until GPS satellites got invented, this is what you had to do. If you wish to become a pilot, you still have to prove that you can do this stuff. Simple example why is, what if the communications go down? What if there's a glitch in your computer? How are you going to find your way home? Now continuing, one of the other pieces that we'll note, a lot of the problems that you have are not going to actually ask you to prove something. I want to make certain that you pay attention to what the directions ask, because we've seen when the directions say explain why they are congruent, that's a proof. When they tell you prove, that's a proof. This one does not say prove it. Determine if you can use it. You are not being asked to explain why these things are congruent. You're not being asked if they are congruent. You're simply being asked, does this tool actually work? Can you use the full checklist of having a first pair of angles, a second pair of angles, a pair of sides, and the order? Do you actually have all of that? Well, the angles parts are easy. We, of course, get those just by the tick marks. There's also the shared side. Of course, the shared side gives it to you. But is the order correct? Here's an angle, and the side. To use angle, side, angle, we have to have the included side. Is that side in between the two angles you're using? No. And because we do not have the correct order, we can't use angle, side, angle. And we know that we can't use it because the order is wrong. We were not able to check off the order box in our checklist. That's why we can't use it. Okay, one more, run through it. Can you use angle side angle? Well, of course we can see we've got the shared side, so the side part's not a problem. And we would also be able to say, because of the parallels, well, we've got parallels with the transversal, we know that we could say that we've got a pair of alternate interior angles that are the same. And so we've got that. Do you have the last angle? And just to change it, remember this would be saying angle connected to side connected to angle. We would need those angles in the red. Do you know with certainty that those are the same? No. No, we don't. And this is where you've got to be careful, because a lot of times students will look at this picture and say, well, yeah, those are alternate interior angles. Keep in mind, when we are considering parallel, we've got our whole parallels, we've got our whole transversal, and we've got alternate interior angles for those two. That's true. But when we start talking about parallel lines, we don't have this piece and this one matching up. With our transversal, we have the entire obtuse angle being congruent. And that does not instantly guarantee us that these other ones would be as well. In order to make the statement that we know these two with the yellow are congruent, we would also have to know that the other pair of sides are parallel also. And we are not given that information right now, so we can't say with certainty that these are. Can we use angle side angle? No. And we can't do it because we don't have two pairs of congruent corresponding angles. We don't finish off the checklist. And Chance, when we go back to what you were commenting earlier about that third angle, that's exactly what we're going to get here. Our second tool that we will have is the angle side theorem. And same way that we had before, we'll have our first pair of angles, a second pair of angles, a first pair of side, and the order angle connecting to angle connecting to side. In terms of its picture, these are the ones that look like having an angle and an angle, but the big difference is the side that we're using is not included. The side pair is not in between the two angles, it's outside the two angles. And of course, this is an immediate consequence of angle side angle. As you observe, Chance, if we know two pairs of angles, the third angles theorem tells us what the third one would be. And having the third one then sets up angle side angle. This one only works because angle side angle works to begin with. So the kinds of things that we would use with this, well, we could actually be asked to prove it. Prove that these two triangles are congruent. Well, if we're going to go through and prove them, let's go through and get our checklist. The first pair of angles that we have, angle X congruent to angle B, it's given. Okay, so that's saying that one is congruent to this one. And I'm looking out at some faces right now, and I'm seeing a lot of people looking at the picture a little bit confused, like they're trying to see which triangles that they're working with. Glad to see that you're focusing on it. I also want to remind you of a technique that can sometimes be helpful. When we've got overlapping triangles or pictures that kind of overlap on top of each other, we can redraw it and pull them apart from each other. In particular, triangle XYZ, that's the one here over on the left. So we can draw it X, Y, Z, and we've already got that. I'm sorry, X, Y, W, what am I doing? X, Y, Z, there. Multiply, picture. Okay, so there, and this, there we go. There's X, Y, Z. And then we're looking at VYW, V to Y, W. And just to help kind of simplify the picture a little bit, V, Y, W, we've got those. Not a perfect picture, but they don't need to be. We're just putting it down to try to help us visualize a little bit better. Okay, so right there, we've got our first pair of angles. YZW, congruent to YWZ. That's telling us YZW, congruent to YWZ. We've got those two pieces being congruent. Well, is that in our list of angles? Is that something that's going to help us out with the checklist? Not directly, not as an immediate one step. What we would need to put down, angle YZW is congruent to angle YWZ. That piece is given to us. And I'm going to notice then that angle YZW, that's of course this one, is supplementary with angle YZX. That one. Why are they supplementary? They're a linear pair. Linear pairs are always supplementary. Similarly, we could do the same thing on the right-hand side. Angle YWZ is supplementary to angle YWV. That's saying the one here on the right is supplementary to that one. And we know that because a linear pair gives you supplementary angles. That was one of our theorems going all the way back to the first unit. Well, all of this stuff in the red was designed to get us one thing. In our third unit of the year, we had the congruent supplements theorem. The congruent supplements theorem says if you have a pair of congruent angles, like right here, and you know that they are both supplementary to two other angles, that forces these other two angles to be congruent. All of this stuff in the red was designed so that we could get angle YZX congruent to angle YWV because of the congruent supplements theorem. So what this winds up giving us then is we've had our first pair of angles. All of this stuff in the red was used to get just the second pair of angles. And then we'll use our given XY is congruent to VY. That gives us our side. And since we've got the order, angle, angle, side, we could finish it off and simply say triangle XYZ is congruent to triangle VYW by angle, angle, side. last theorem that we are going to have is hypotenuse leg, or at least the last one we have today. Hypotenuse leg has our checklist. Well, first of all, this one only works for right triangles. If you don't have a right triangle, this cannot be used at all. And it quite simply says you have a pair of congruent hypotenuses and you have one pair of congruent legs. That's it. If you can finish off our checklist of it's a right triangle and you have a pair of congruent hypotenuses and you have a pair of congruent legs, those are things that would force the triangles to be overall congruent. So, can you use it? Is this a problem where you could actually finish off and know with certainty that you have all three things finished?
Yeah.
So first of all, right triangle, you bet. We've got a 90. And of course, that would be a 90 on the right as well. So it's a right triangle, got it. Do you have a pair of congruent hypotenuses? Yes. We're given that right there with the tick marks. Do you have a pair of congruent legs? You bet, they share a side. The shared side is going to be congruent because of the reflexive property. Got it. Can you use it? Yes, you can. Those will be congruent triangles. And if we were actually asked to prove it, all we would do is write up a sentence for each thing on our checklist. What about here? Can you say that these two are congruent? Well, our checklist are right triangles, congruent hypotenuses, congruent legs. You got them? Right triangle, absolutely. Tick marks give us a pair of congruents. Those, though, are a pair of legs. Got it. What about hypotenuses? Of course, the hypotenuse is right here. Do we know with certainty that those are congruent? And I'm seeing a whole lot of people shaking their head no. So we don't know. We don't know if they're congruent or not. There's nothing that says they're different. We just don't know. And so can we use hypotenuse leg? Nope. We can't use hypotenuse leg. And remember what the directions told us? If you can't use it, what else do you need to know? Well, what else do we need to know? What else haven't we finished with our checklist? We need the congruent hypotenuses. We don't have them yet. Maybe there's some other way to start going after it and figure it out. Maybe there's not. It just depends on the problem. But right now, we don't know. Last one for the day. Can you use hypotenuse leg? Seeing a whole lot of people shaking their head yes. So if that's the case, we'd have to recognize 90 matching 90. We've got a right triangle. The tick marks are telling us that we have a pair of congruent hypotenuses. We've got that. And with a shared side, the reflexive or symmetric property will tell us that we've got a pair of congruent legs. So yes, we do. We can use hypotenuse leg. And we're done, because the directions didn't ask us to actually go through and do it. They just said, can you do it? Pay attention to the directions, because I know that it's really frustrating for students when they look at this and say, oh my God, Mr. Fryer, there are so many proofs. And it turns out there are so many proofs because you're doing proofs when you're not asked to do a proof. Make sure you pay attention to the directions and actually do what you're asked. You don't want to create more work for yourself.